Hey everyone, and thanks for listening to the Metis Tech Show. Today we're going to be talking about voltage vital signs, but first, the Metis Minute.
Today's Metis Minute is on nomenclature. So the City Multi products have their own unique nomenclature or naming convention. Each letter and number in the product code sequence provides details about the specific model. For example, in an R2 system, the R stands for heat recovery, whereas with a Y series, that same indication would be an H. On outdoor units, the model number can be found on a silver decal, typically located near the base of the unit. For indoor units, the model number will appear on a clear decal located either on the bottom or side of the unit. For ceiling recessed or ducted units, the model number can be found on the chassis of the unit. Thanks for listening to today's Metis Minute. Now let's start the show.
The Metis Tech Show.
Welcome to the Metis Tech Show, a show for HVAC professionals by HVAC professionals.
I like how you guys bounce back and forth between heat pump talk and food talk.
The Metis Tech Show.
Mitsubishi.
All right, so we're going to Red Ginger tonight,
Yeah.
and that's basically Chinese food.
Mm-hmm.
But my favorite thing they have is, well, let me back up. One of the problems I have when I go out to eat is I'm indecisive.
Yeah.
Do I want, the other night was, do I want wings or do I want pizza? But, I get the bento box there at Red Ginger, which is, or as Gary would say, the Benito box.
Benito box.
The bento box. So it has a little bit of a salad. It has some gyoza on it. It has some rolls. What else is on it?
Sushi.
Yeah, California roll, gyoza,
Yeah.
egg roll, and then your
Egg
main.
roll.
And your main, which could be Mongolian beef, it could
Yeah.
be Generals, it could be whatever you
You get a
want.
little bit of everything. It's, like tapas, but not Spanish.
So, Paul, what's your favorite main Chinese dish?
I like beef and garlic.
Beef. Okay.
Oh,
Yeah, that's a good one.
I'm an egg foo young person. If it's done right, it's good.
What is it?
Egg
Yeah.
foo young.
Oh,
It's like
yeah,
a
yeah,
patty of egg and
Yep.
there's chopped onion there.
The other thing with that is like if it's a Chinese food place that I know and it's like my spot, I'll get adventurous. But if you're like somewhere random, it's the first time I ever tried it, I always just go with the General Tso's chicken. It's not like, the most high class Chinese food, but it's generally the safe option.
That or Mongolian beef.
Yeah,
Mongolian
that can be
beef
good.
is good.
Yeah.
Yeah.
Yeah, with Chinese food, I can't say that I've tried everything. I'm gonna make up the numbers, but it's not an exaggeration. If I've been to 1,000 Chinese places, I've probably had 5 dishes.
Yeah.
Same here. Yeah. Same here.
It's true.
It's not like I'm going to try something. I'm not going to try. That's like me in Italian restaurants.
Mm-hmm.
If I go to an Italian restaurant I've never been before, I'm always going to get the chicken parm.
Really?
Right? Always. It's
That's
my
your
first,
go-to?
It's my go-to.
I had chicken
And-
parm last week.
Yeah, and I keep saying I'm going to try something different, and I get there and I go, I'll have the chicken parm.
It's funny. My go-to is lasagna. Every Italian, because that to me will paint the picture. If it's good
Decent
sauce, good
spot.
meat.
Yeah.
I mean, if it's good, I know everything else is good.
Lasagna is one of those things that's made so different. And like I had, where was I? It was someplace they had lasagna. It was like a buffet. It was a catered event. It was a graduation party. And it looked awful. And I didn't even try it, but they had chicken parm, so I went for that. And the other thing about lasagna, not to sound snobby or anything, but I've never had a lasagna anywhere in a restaurant as good as homemade. Ever.
Wow.
Yeah, that's true.
Yeah,
I think
I mean-
there's some really good homemade
Yeah.
lasagna.
Yeah.
Yeah.
I get it.
And then one time somebody snuck in eggplant lasagna, and that was disgusting.
Yeah, I'm passing.
Yeah.
A little
No.
bit of basil on the bottom of the lasagna. Oh, yeah.
You know what makes me lose respect for a
stuff.
Chinese food restaurant is when you order and they don't bring over the crispy noodles with
Crunchy
duck
noodles?
sauce.
Oh, the crunchy noodles.
If they don't bring that to the table, I'm like,
those are the
is this
best.
even a Chinese food restaurant?
Yeah, I love those things.
Tea is the best thing there.
The tea.
Tea.
Oolong tea.
Oh.
The little
Yeah.
tea, the little,
You're very
yeah,
right.
In the cup.
Yeah.
yeah.
They brew it a
Smallest
special
cup.
way.
I think now it's just a memory for when I was a kid.
Yeah.
I think that's
Nostalgia.
Exactly.
Yeah.
Yep.
100%.
Yeah. It's good, but
Yeah, and my kids, they want to go change. Can we get a poo-poo platter for 2? For yourself? Yeah. And then he won't eat like half the stuff on there.
no, do you like egg drop soup?
Who?
Yeah. Yeah.
Egg drop soup.
No, no, I don't like miso soup. I don't like any of the soups. The only soup I really like in Asian restaurants is tom yum soup.
Tom yum soup.
I
Yeah.
love that.
I don't think
Some
I
glass
what-
noodles.
I don't think I know that.
Tom yum soup
yeah.
has glass noodles in it and like shaves of like ginger.
Oh,
Yeah. Spicy.
yeah. I don't think. Ooh, okay.
I could do
Spicy, I'll
it. I
try
could do it.
but I don't think
It's a
I-
little spicy. It's not much.
Yeah.
No wonton soup for you.
No, don't like any of the soups.
No La Choy.
What?
La Choy. La Choy is Chinese food, swing American.
Oh, okay. We're gonna have to cut that out. All right. So anyway, welcome everybody to the Metis Tech Show. My name is Paul Shavs, and we're on location at the Swanee office. And joining me is Bryn Raptor. Bryn, say hi.
Hi.
Who else is here? Gary.
Gary O's.
Gary Ozer has not been here in a while. Welcome
I haven't
back,
been
Gary.
to Swanee since last year.
I'm
And haven't-
talking about being on the show.
Oh, the show.
He was on not too long ago.
It wasn't.
You just weren't.
So
I wasn't.
pushy.
Yeah.
Oh,
it's-
it must have
it's
been
good,
when I was out of town.
Haven't had the mic in the set up and anything, so it's very good. Nice to
All
be
right.
back. Yeah.
And once again, Scott, it's been a while since you've
It
been
has
on.
been a minute
you know,
for me. Yeah.
So
minute.
welcome, Scott Tallman.
Thanks.
And so what are we going to talk about today?
So we're going to talk about some what I call voltage vitals. Like we talk a lot about on multiple episodes. We've had conversations about maintenance tool vitals where we're looking at pressures and temperatures, and we may not break down every thermistor or every pressure check, but just the main ones we look at. Those first checks that we make. So I thought we could take that same theory that we take with maintenance tool and apply it to just voltages at all of our different equipment, whether it's outdoor units, commercial, residential, just those initial, here's what I'm going to do with my meter as soon as I walk up to a unit that's not working.
A good idea because every technician should have a meter. If you don't, quit your job. Thank you. Don't go on a service call without a meter.
Great subject to bring up is meters.
But not everybody has maintenance tool, but everybody has a
A
meter.
meter.
Sure.
I know.
Quality of a meter makes a whole big difference. There's a lot of good quality meters, and one meter might be different from the next meter.
You want a true RMS meter is what I think
1,000
we
volt
recommend.
rated. Yep.
Yeah. All right, so let's just go then, line by line. So let's start with a smart multi.
Sure.
All right, I come up to a smart multi. So are we going to make the assumption that we've already checked L1 and L2?
But
In some cases, yeah.
Yeah, but we should always.
always
Right.
check.
That's the first check I'm doing,
So
anyways.
it's going to be 208, 230.
Yeah.
And we also have now three-phase smart multi.
Correct. So we have to make sure that just know 6, 8, and 10 ton, 3-phase.
Yeah, 6, 8, 10 ton three-phase and make sure that just the phases are equal.
Yep.
And that's all.
Correct.
That's it.
Yep.
And then, okay, so I'm checking in general service call, general things to check. So where do I start? Let's just assume, again, line voltage is done. I got 208, 230, the single phase or three phase. Let's assume that's done. Where would I go next?
So honestly, the first place I'm going to check is my M1, M2, my MNet.
You're right there.
Just see if I'm communicating. I'm going to check for 29 volts DC there. And I think before we get too far into this, is let's say you walk up to a unit and it's not throwing an error code, but also nothing is happening. You can't get the units to kick on. This is where those voltage checks get really helpful.
Correct.
Is I don't have an error code, but for some reason, either something didn't show up in my MNet search or it's not, I can't command a specific unit on, or nothing is working. So these are the places that I'm going to check.
It all starts with the outdoor unit.
So, and going to your point, Bren, right? When we lose that MNet, right? No error code typically does not display.
Yeah.
Now, those on the call, the listeners, please pay attention that this is for our 410A equipment. When we go to the R54B, it will now throw an error code.
Yes.
Right away.
Yep.
So just wanted to kind of let you guys know if you guys did not know that.
Yeah, we used to have this issue with the 410A equipment that if there was 0 volts on M1, M2, nothing happens.
Nothing.
It looks like it's flagged
just
out. It's ready
dormant.
to operate.
It just sits there.
Now it throws a 7102, thankfully.
All right.
Yeah.
So this is a smart multi, and we got the voltage in there, TB3, M1 and M2, and it's a steady 29 volts DC.
Yes.
Not to confuse people with M&P product, not a bouncing. Steady 29 volts DC. Next step.
The next one it's sitting right next to it is B1, B2.
Sure.
That is your 208 voltage to your branch box.
Yep.
So just to be careful of that. There is a fuse behind that link to that terminal block. So if you get zero.
Providing if we're going to residential equipment or if we're going to commercial equipment.
Yeah,
B2 is not utilized in commercial.
correct.
Yep. I also am going to check CNDC on my control board, usually on the left-hand side. You can't miss it. It's a hot pink plug.
Yep.
It's not just on Smart Multi. It's on other equipment, but we'll get to that. But CNDC, that 300 volts DC powers that board. So that's why I use that one. That's like my first check.
That's your go-to, right?
Because if I don't have LEDs on my screen, well, let me see what my DC voltage is. Yeah. Check that hot pink plug, right? Leave it plugged into the board. You need needle leads so you can back probe that connector, looking for that 300 volts DC.
Okay, so question for you. If I don't have 300 volts DC, let's say for whatever reason I don't have 300 volts DC,
Sure.
will I have 29 volts DC?
You could, potentially.
You potentially.
You could? Okay.
Yeah. So on a Smart Multi, yes. On something like a M&P series, which we'll get into, no.
Okay. That's a good thing. And if I have incoming up, I have L1 and L2, 208, 230. I don't have 300 volts DC.
Mm-hmm.
What's next?
I'm going to work back to my power board. All right,
because your LED screen is going to be blank.
Yeah. So if I don't have 300 volts DC on my control board, I need to make sure, do I have it coming out of my power board? All right. Because that's what's actually providing that 300 volts DC. So if I have it on my power board, but not on my control board, it could be the harness. Right. And so that's what I try to nail home too, is like, don't condemn a board for a bad harness. Check either side of that harness, because a loose wire, up in the Northeast, we get mice and stuff that chew through it. So check voltage on either side of the harness, right? If I don't have it off of my power board, I'm going to make sure my power board is getting voltage. If my power board has voltage, but it's not coming out, it's a bad power board.
Yep.
Okay.
So we work our way back, but obviously at that point, you're taking boards out of the system, right? So that's why, these are just more your vital checks, right? But anything beyond this, you're going to be pulling boards out to check
what
voltages.
comes in must go out.
Yep.
Follow your path.
And the reason why you would, if we don't get 300 DC, right, but we still have MNet, because we have an MNet board that's powered separately.
Yep.
So
Yeah, so we can talk about that actually while we're on the topic. So on MNet, on Smart Multi systems, there's a MNet power board. It's on the back side of your control
right.
board.
Yep. Exactly.
It's that power board is fed 208, 230, and then coming out of it on CN2 of the power board, the MNet power board, goes to our control board on CN102. But you'll see 4 wires, even though it's DC.
Correct.
The reason for that is pins 1 and 2 feed TB3, and pins 3 and 4 feed TB7 if needed.
Yeah.
So we want to check our red and white plug on CN102 for 29 volts. And then we want to check our yellow and blue wires on CN102 for 29 volts. They should both have 29.
Yeah, and you will get it. And not to confuse people, right? Because what will happen, they'll read TB7 terminal block and read 0.
Yep.
But we'll get the voltage on pins 3 and 4 on that connector CN102.
Right.
And the reason why is because you have that jumper sitting on CN41 that in the off position, that preventing voltage going to TB7.
Yeah. We really only use TB7 for if we have, on a Smart Multi, it's very rare unless it's part of a larger system like a City Multi or commercial application. You're
Like more circuits, more other
you're trying
more
to pull
systems.
in
More systems,
refrigerant
yeah.
systems
Yep.
without a central controller.
And then another important voltage, I think, is the reversing valve.
Yep.
And let's talk about what voltage we have on the reversing valve and when.
Yeah. So your connector for checking that reversing valve is 21S4, and that's what we call our reversing valves, 21S4. You'll see it on the connector as well. And we're looking for 208, 230, and that is in heat mode for almost every single one of our units.
But
But our ported non-hyperheats.
yeah. And to follow up to your point, Brent, about the 21S for the reversing valve, that 208 is coming from the connector from our noise filter board on the control board is CNAC connector.
Yep.
Or for 208.
Yeah, so we do also bring 208, 230 to that control board on CNAC, and that's for all reversing valves and all solenoid valves, which
Correct.
come off of the control
That's
board.
a point to really drive home is
Yeah.
208, 230 volt single phase going to those four-way reversing valves as well as the solenoid valves.
Yep.
Yep.
All right, and let's just back up a little, getting back to the meters. These are checks that we're doing without unplugging.
Correct. We're
Anything,
going right.
right?
We're going
So-
right through the connector.
So we need those hypodermic or those needle leads.
Yeah. Yep. Well, yeah, and
Skinny
the thing
leads,
is that
micro leads.
the purpose of these particular checks is that there is no need to remove a board to check these.
correct.
These are all the checks that with the power on, boards in place, we can check and give us an idea of how that system's working.
All right.
Or if it's working.
And then there's one more voltage that's a vital voltage, right?
You got it. So that's our UV and W going to our compressor, right? We want to make sure that that's balanced AC voltage.
Right, and I want to just warn people on this one. The one place you don't want to take this reading is at the compressor terminals.
Well, they're
Absolutely
plugged in.
not.
Yeah, no, I've seen people do. I've told people in class don't do that. I've seen them do it, and it usually results in a bright flash with a simultaneous loud bang, and then the soiling of the pants.
It's like, don't touch that hot plate. What are you going to do? You touch the plate.
So where do we take this reading?
If you're asking me personally, on a smart multi in particular, I'm going to power down the system, pull my wires off the
Yes.
compressor, and then check under no load.
Absolutely.
Yeah. So in some of our other equipment, we have the inverter checker, which will do the job for us, but we don't have that same harness on a smart multi to plug in that.
No, but
inverter
what
checker.
you do have in the inverter checker, those giant alligator
Yeah,
clips.
alligator clips.
That are inside. Because the one thing you want to be careful with, you power it down, you unplug UV and W from the compressor, you're going to go check it. Now you want to make sure they don't touch each other. They're not even close to each other. You got to separate them. The alligator clips that come with the inverter checker, which everybody should have, I think it's worth it, is now you use the alligator clip. It's a little bit insulated, and it's easier to keep them away from each other. There's no arcing.
Sure.
Because what happens if you measure at the compressor, at the terminals, they're nice and close together, and that voltage is going to arc across your leads, and it's not fun.
No.
But Paul, it's AC voltage.
Separate
So
discussion.
the only,
This is why you're not on the show a lot.
so the only drawback to the Gator clips would be that you're not going to see a voltage. What you're going to see is the actual IGBT switching. So you'll
Correct.
see 6 LEDs. At first, they kind of start slow, and then they ramp up, and eventually they just look like they're all on. If they're all on, your inverters are switching, or your IGBTs are switching.
Which is cool when you do that. Actually, get your phone out and record it on your phone. You can actually see the gates opening, quote unquote, the gates actually opening and close within that pattern.
Yeah.
You can see the wave pattern. It's actually pretty cool to do it on your phone.
Yeah, switch it to slow mo.
Let's go. That AC, it's simulated AC voltage that's on there. It has a hint of DC.
Yeah,
Yeah.
So we're going to be very
treat
careful.
it like DC.
Yep.
Yeah, all the
So
characteristics of DC.
So,
Bring some cardboard, and if you need some additional space to separate those wires, or a rag.
when we do the inverter test, are we going to do make sure we put the smart multi in the inverter test,
Yep.
right?
Yeah, so
we
it's
have to
dip
make
switches
sure.
on the outdoor unit.
Correct.
Use your service manual, figure out which dip switches to turn on, and basically all you're doing is telling the system, I'm doing a no load run on the compressor.
And it ignores errors in the system, innocently.
You've got
On the smart multi, it's been a while since I've opened one up, but can I go back to the board, UV and W on the board, and measure there, or is that one of those behind the other
It's
board?
behind.
behind
it.
it.
Yeah,
It's
off the power
Yeah,
board.
so I'm not going to go through that trouble to do it. If I don't have an inverter checker, I'm going to do what Bryn said: power it down, take it off, and measure it that way.
yeah.
Yep.
All right. So now, what's next topic?
Let's move to City Multi. So we're already in the MNet realm. So before we go over to M&P series, let's stay in the MNet realm and go to City Multi equipment. And we'll start at the outdoor unit, just because we're already on outdoor units. Our outdoor units are 3-phase, right?
Yep.
It's either going to be 208, 230, 3-phase, or
L1,
460.
A 1
3-phase.
L2 L3
Yep.
across the lines and each the ground.
Yep, exactly. And we just want to.
I'm sorry. A question I get a lot is, do you have to reverse the 3-phase? Like, do you have to check to see if anything's running backwards?
No, we want to run our compressors
Yeah,
backwards.
electricians have that all the time,
Yeah.
especially around a 460. Your BOY on there, brown, orange, yellow, just leave it alone because the boards take care of it for you.
Yep.
That's part of the beauty of the inverter.
Inverter,
right?
yep.
It's not a unitary; it's an inverter. So we're just taking in that voltage. We're making our own simulated AC voltage to drive
right.
the compressor.
So we checked L1, L2, L3. We got the proper incoming voltage. What's another important voltage?
So I'm going to check my RYPN plug. So if you're looking at the control, now this is on NGen equipment, but if you're looking at where your power comes in, kind of down and to the left, there's this little black connector with 2 pins on the outer 2 pin mounts.
Yeah, pins 1 and 5. Yeah.
And that is actually your DC voltage through your diode stack.
Yep.
So on a 208, 230 unit, it should be 300 volts DC. On a 460 unit, you should see 600 volts DC.
In that neighborhood, it's not going to be exactly 300 or exactly 600 because the incoming voltages, as we all know, can vary.
Correct.
Let's just say plus or minus 10%.
Sure. Yeah.
And it's about 300 volts.
Yeah,
Yeah,
it's
roughly.
It's going
Plus
to be
or
a
minus.
factor of the incoming voltage and load conditions.
Correct.
Yeah, that's That's actually one of my favorite test points.
Yeah.
On an engine.
Now, on those test points, they have that pin 5 on that black plug. Why is there a gap in there?
For arcing. Test for DC
Arcing,
voltage.
yeah. And that's also another place we're going to utilize those micro leads, those skinny leads, because it has the leads that go in there with a Teflon wrapped around and just a little point on the end.
Yeah, you definitely got to be careful testing.
Yeah.
I think I have a video of Austin not being careful.
Yeah.
I might show it in class sometimes.
Another thing with that plug, though, for safety measures, right? If you want to start opening up the going in the engine, trying to find the power board and whatnot. If you test when you turn off power, right, and if you put your leads on pins 1 and 5 in our YPN plug, if you're reading 20 DC or less, then it's safe to go in. Yeah.
So our capacitors need to discharge.
Oh yeah.
So that is a good place to check to say, hey, is it safe for me to start sticking my hands in this equipment?
Yeah.
Check that plug, that RYPN plug, little black plug. Make sure it's under 20 volts, and then
you're good to go.
you're safe to start.
I think the manual gives you a time and how long that you should wait. I used to tell people wait for all the lights to go off, but I think I've mentioned this before a long time ago. But at the Boston Training Center, I started there 13 or 14 years ago, whenever it was, and we moved from one training center to another just before I started. In the Y series unit, I'm sorry, not the Y series unit, the Smart Multi, the old S series unit that came from the old training center, had been sitting in that loading dock in the warehouse for probably 7 or 8 years. And we went to get a board out of it because we needed it for another system. And the board sparked. I mean, it wasn't enough to hurt or anything, but it shows after 7 or 8 years sitting there with no power attached to it, there was still some capacitors in there holding a small charge. So yeah, that's a good test. That 20 volts, don't touch it until it gets down there.
And that's our DC bus. We're talking about those 300 volts. Like, what is it? That's our DC bus in those terms.
Yeah.
Yeah. Right. And let's talk about another important thing is don't unplug or plug anything in with the power on because it will arc and you'll fry something.
Yes. Yeah. You got to be really careful.
So never plug. That's a rule. Don't plug it in or unplug it with the power on, period.
Now, one thing I'll just add because we're on the topic of the RYPN plug is you've got your 300 volts DC there. So that's a check of through your power board, right? We're making sure those diodes are converting into DC. Just above it, you've got your little view window back to the inverter board.
Yeah.
If you look back there, you'll see the LEDs on the inverter board. And the big thing I say is just make sure nothing's blinking. You're going to see lights on. Just make sure nothing's blinking. If it's blinking, that means that inverter's in error. So that's 2 quick checks before you even have to take a board apart to see what's wrong, what's going on with my inverter. Do I have the actual DC voltage going to my IGBTs? Yes, no, right? We can work backwards or forwards from there and then look at those LEDs, make sure nothing's blinking. If it's blinking, it means that inverter's in error. We start honing in on that inverter board.
And hopefully at that point, it would be an error code will display. Sure. And then when you get an inverter error code, always make sure you double check and get to see if you have a detail code because you'll get a detail code with the inverter.
Yep. Next voltage check.
So I like to check CNPS on my control board. That is coming off of my power supply board, which is responsible for all of the low voltage DC signals in the system. So one of the most popular and important DC signals in the system is my MNET.
Yep.
So off of my MNET power supply board, which is behind the control board, we get this CNPS connector. That's my 29 volts DC for TB3 and TB7.
Nice.
Right. And as you mentioned, TB3, 29 volts.
Yep.
DC.
Constant. We should always have 29 volts on TB3.
Constant. Yeah. Yep.
When we move to TB7, however, right, we want to make sure that when we power it on for the first time, it has 0 volts. The only time it should have voltage is if there's a central controller where the central controller is powered separately and provides that voltage to TB7, or we have the jumper that Scott mentioned earlier from CN41 moved to CN40. Right.
Yeah.
If we power on and we've got voltage on TB7, we've got some issues. Something's not right.
That's a very common fault on a startup.
Yeah.
Is TB3 and TB7 get reversed. This is why when you're running these MNET wires, they should be labeled at both ends, properly marked. Yeah. And even though it's not required, I think it's a good practice on M1 and M2 on TB3. If you're going to use red and white, use red and white, use the same sequence. Keep it polarity sensitive, even though it doesn't
Not
matter.
required, yeah.
It's just a good practice, I think.
So what I do with TB3 and TB7 when I tell my class is if you're confused on what is what, pull those wires off. Measure which one has voltage. If you have voltage, it's coming from your AE200 TB7. If you're in zero, that's going to TB3. That's the easiest check you can do.
Yeah, and if you're twinning modules or at 3 modules on a Y series, you got to make sure they're all the same. This TB3 to TB3 to TB3, TB7, TB,
Correct.
because that gets reversed a lot.
Exactly.
If you reverse TB3 and TB7 on one segment, one module, and not the other. It's going to throw you capacity errors. And,
Now,
To throw a wrench into that, if you have multiple systems on that bus line, now you have to go through the painful task of ringing the wires out to find out where you lost it and where it's crossed up. And that's
bringing in
torture.
a bunch of systems.
Yeah.
So I always say, single module or dual module system, you think you have TB3 and TB7 cross, power it down and check where the voltage is.
Yeah.
And if you got it on TB7, you're not crossed. If you have it on TB3, you're crossed.
And if we are crossed, didn't catch it yet, what typically do we have when we start the equipment up?
You're stuck in a scroll.
You're stuck in scroll. Yep.
So besides checking the MNET voltage, other voltages on the control board would be CNAC, just like with our Smart Multi. We need that 208, 230 there for all of our reversing valves and solenoid valves.
Yep.
Whether it's a 208, 230 or a 460 unit, it's always 208, 230 solenoid valves, reversing valves. So do not forget that. If you see that CNAC plug on the control board, it's always 208, 230.
Across all our product lines.
Yep.
Correct. Yep.
Thermistors, I do like to check those sometimes, especially if I have an error code for thermistors. Obviously you want to ohm them out, but what if they ohm out okay? Sometimes I do like to check the voltage coming off of those. Typically they put like a 5-volt DC output. Sometimes it's a little less. Typically when I check, it's been 5 volts, but it's helpful to know. It's just like your meter, right? Your meter has to put out a small amount of DC voltage in order to measure that resistance. So same thing's happening with our board. So it's another check to make.
Also, a good check is like non-voltage related is to make sure those plugs are secured into the
Plugged in.
those Molex plugs are in there. Things do shift in shipment.
Yeah.
So something to go on and start up to when the power is down is to check those Molex plugs.
Yep.
Yeah, Brent, to your point about, checking thermistors, making sure that the board is outputting what it needs to that, correct?
Yeah.
LEV, same way.
Yeah.
Obviously, a meter can't pick that up, but if you get an analog meter, you can check the outputs and see that the needle bouncing, making sure the board is doing what it needs to do, rather than is it really an LEV or a board? That's just a good way of doing that.
Yeah, the board, LEVs are tough for voltage, like you said, because we're pulsing. I mean, if you ever listen to our system start up, all that clicking, that's a 12-volt DC pulse to drive that LEV open or close. Either meter doesn't typically keep up, but with an analog, like you said, you'll at least see that fluctuation.
You will see that,
every
and
time
you know
pulse
that the
hits.
board is doing what it needs to do.
Yeah.
So
And then with City Multi equipment, we have 3 components that have that balanced 3-phase AC to check, right? So we have our compressor, but we also have our 2 fan motors, right?
Correct.
So again, this is something we can check without having to remove a single board.
Which is nice.
Yeah, if you look at that control board on the left-hand side, you'll see 2 connectors, white connectors with black, white, and red wires and a tag. And the tag will say fan motor right, fan motor left. So we can test those for balanced voltage just like we do with our compressor. Now, Scott, we do have to do something with the outdoor unit in order to make that check. We started talking about it with the Smart Multi, but we have to do it with City Multi too.
Yeah, so for the compressor, we have to do a inverter test. Obviously, we have to let them know the system that, because in essence, we're taking the compressor offline, right. And so if you can make a test run through a unit to get a call. You can do it different ways. You can do this. But the system, when you're starting up a system, is looking at pressures and all that. If it doesn't meet that, 14 PSI at startup, it's going to go right in error. Yeah. So if we go hit dip switch 7-1 for a compressor, that's inverter test, so ignores that.
Ignores the fact that it's not moving any refrigerant.
Correct. Exactly.
Yeah.
And then what you have for if you're doing an inverter test for your fan motors, so on your left fan, you're going to turn on 7-2. On your right fan, you're going to turn on dip switch 7-4.
Yep. And like you said, we're basically just telling the system, hey, this is a no load condition.
No load. Yep, exactly.
Make sure you put those back in the on position.
Thank you. Okay.
Yeah, we don't want to ignore
You'd be
errors.
surprised.
It happens.
It happens. Yeah.
I know. Yeah.
Yep. And then the last one with outdoor units on City Multi would be CNRYA. That's our relay to our noise filter for the compressor. So it's a 12-volt DC output when our relay 72C energizes to the noise filter, which is it acts as our contactor.
Right. It's what it is.
For the
And
compressor.
what's another system indicator?
So when you're looking at the LED screens, we talk about that flagging out, and each one of those flags does represent something that's energized in the system. It could
Correct.
be a reversing valve, could be the microprocessor, but that very first one on the far left, when I see that light up, I call it like my call for the compressor. to come
Compressor.
on.
Yep.
And what it really is that relay's been
It's
energized.
been, exactly.
Yep.
All right.
Yeah.
So should we move to the indoor unit?
We should.
Okay. And this is pretty much standard for no matter what indoor unit you have.
Yeah.
All right.
Yep.
L1 and L2, it's 208, 230. Now, we used to, back in the day, have a 3-phase indoor unit. That's been phased out, I think, for a while.
Really?
You may still find an old, I think it was a high static PEFY.
I didn't
was
know
a
that.
3-phase indoor motor.
Yeah.
But for a while now, so you might have that one, you might find one's been installed for years.
Oh, yeah.
Yeah.
But right now, the ones being installed today, they're all 208, 230 single phase.
Yep.
Nice. Okay.
And then we can move on to verifying communication at TB5. We want that 29 volts
29,
there. That's
yep.
also what's going to power an ME controller. So we want to make sure that 29 volts is there.
Yeah, don't be shocked you have 3 separate wires on TB5.
Yep.
So, yeah.
TB15, that's our MA controller. We want to make sure we have 12 volts DC there.
Very common to swap those two.
Yeah.
Brandon and I were just talking about that.
Yeah, you'll notice I made a note for voltage on controllers. Sometimes it's beneficial to check. It's hard to tell, right? If you use all 16.2 for the whole job, whether it's an MA or ME, wires are run behind walls. You don't know where those wires are going. But if you go to your controller, pull the cover off, be careful, pull the cover off, you'll see your terminal block, and you can check it for voltage. If you have an ME controller with 12 volts on it, you're on TB15, you got to swap it.
Oh, it'll light up that ME.
Right, it'll still power it.
Yeah.
Another thing to look out for on the ME is that on the quartz screen, in the very bottom right corner, if you see a little dot there, that means you have 12 volts. You don't have to take the plate off the wall.
Yep.
Yeah.
Yep.
Good point.
Good to know.
Yeah.
Nice.
Little tiny dot.
Yeah.
All right, and then we got, so what else is in the indoor unit? There's going to be the motors, the fans.
Oh, fan motor is probably one of the most important checks
Yeah.
for if the board is being supplied with power, because you were taking 208 into the board, right, from L1, L2, and then we hit a diode stack, and then we send that 300 DC to pins 1 and 4 or pins 1 and 3, just depending on what size indoor head it is.
Yeah.
For a concept for 300 DC.
Right. Yeah, that's our power into the fan motor. Now, we'll get into it in a bit about testing all fan pin outs, but this is the power into the fan motor, but it is also our DC bus and powering a lot of our low voltage DC.
It's our low
in there.
voltage DC.
And I'll tell you, I was in LA and there was a bad board on a wall mount.
Was that what it was?
And we did an address search, right? There was a City Multi equipment. So we did an address search and only one unit did not come back. And that was this particular unit. So I walked up to it, checked L1, L2, 208, 230. Checked my fan connectors on pin 1 and 3, 0 volts. I'm like, you have a bad board. We're done. Done testing. We don't need to do anything further, right? We're done.
Yeah.
So it's that these are the things that we can do these quick checks and get quick diagnosis from it.
But to your point, Brent, sometimes our mind lets us think like, well, it could be something else.
Yeah.
Right, to your point. No, stop doing it. You're done. You measured 0. It's not 300.
Yeah.
Stop what you're doing,
No,
and
the
that's
board's
it.
not working.
No overthinking. No overthinking.
Yeah.
Yeah. One other thing to talk about with some of our units, it's not on all of them, but 4-way cassettes, 1-way cassettes, any of our sealant concealed ducted units is our pumps. There are 2 different types depending on the unit. So we have the AC pumps, which are 208, 230. And then we also have DC pumps, which are 12 volts DC.
Well, how am I going to tell which one is which?
Oh, it's easy. It's AC's 2-wire, DC 3-wire.
I knew
Simple
that.
as
I
that.
just wanted-
I know.
There he goes again.
Yeah.
and
Paul's
by-
a true MC.
And technically, they're not pumps, just so you know. They're technically atomizers. A drain-up machine, water lift-up mechanism, but they're technically atomizers, like a little slinger
Slinging the water
going
up
in
through the
there.
pipe.
Oh, okay.
Yeah, so it's technically not a pump. So for those ADHD people,
Technically.
Yes.
Got it.
Not actually pumping anything.
it wouldn't be ADHD. I'm sorry, that's a different. I have that. It would be OCD, which is
OCD.
I have that too.
Now, the one thing just to mention
don't you have,
quickly on that is the 2 wires. If you're not using the lift mechanism, you're just using gravity, you can unplug that.
Correct.
If you're using a gravity on a 3-wire situation, you can't unplug it
No.
because it has
Feedback.
rotational feedback.
It'll cause a
So
fault.
you're going to need to either cap it or use it.
Yeah, on City Multi, you can use a dip switch.
Turn it off.
Turn it off. Yeah, but on a
Like a PLA residential.
residential, you're going to have to cap it off.
No.
All right. So we're ready to move over to M&P.
We are.
All right. So M&P, I think we should start at the outdoor unit because everything starts at the outdoor unit.
I like it.
Agreed.
All right. So the outdoor unit, L1, L2,
208, 230.
208,
With the
230.
exception of our 115 unit.
Correct. And that's all single phase.
Correct.
There's no three-phase M&P equipment.
Nope.
And then we got our CNDC. What kind of voltage could I possibly read at something labeled CNDC?
Direct current.
You'd be amazed with that answer.
Just
But
checking for continuity. So that's our hot pink plug, right? We can't miss it. It's the same exact thing with a smart multi. You're going to have it on M&P equipment, P equipment,
P, yeah.
P series.
There is a difference now.
Yep.
300
volts DC only.
Yep.
CNS is another one, right? So we take in 208, 230. CNS is where we get our
That's
S
just-
voltage.
yeah,
our
that's
S1,
that's your
S2,
start
S3.
of your S1, S2, and S3.
Yeah.
Yeah.
Yep. So connector for S. So pins 1 and 2, 208, 230. Pins 2 and 3 is at 24
volts.
volts DC out for communication.
And then what kind of power would I possibly read at a connector that's labeled CNAC?
Well,
Current.
again,
Watts.
Farads.
so from the CNAC connector, God, that's coming from the power board, right?
Yep.
And so that's a 4-pin. So it is pins 1 and 3. That is your 208, 230. That is going to the left side.
CNS one.
Yep. See, and then that's the start. That's your, in essence, power to your head indoor unit.
Yep.
Right. And then your pins 2 and 4, 208, 230. That's power for your solenoid and reversing valve.
You got it.
Yeah.
Yep.
Just note in between the C and AC both going to right and left. Right. What do we have?
Those fuses.
Yeah. Right. Lady.
Yeah. So those fuses with the 410 equipment is a replaceable fuse, which is fantastic.
Oh, yes.
With the A2L equipment, it is no longer a replaceable fuse. I believe that's
Soldered
UL,
in.
Yeah, UL requirements. So it's it's a board at that point. In a pinch, which I can imagine happens sometimes, you could, in theory, solder in a fuse as long as it was sized the same. I don't recommend doing that. Order the board, but we all have to get the heat on sometimes. So. But all we have to do to test that is continuity, right?
Yeah.
We're just checking for continuity across that fuse.
Yep.
Yeah, usually when it flows, but a fuse with a blow means there's a problem elsewhere down the line.
Yep.
Either way, that caused
Verified.
that fuse to blow out.
It could be a drain pump, something that backfed into the board. I mean, you just got to check different things.
Yeah, there's 4 of them. So
Yeah.
All right.
Yep.
And then so L1, L2 comes into the outdoor unit. The outdoor unit sends S1, S2, S3 to the indoor unit, right?
Yeah, so when you're talking S1, S2, and S3, if you measure S1 to S2, 208, S2 to S3, that 12 to 24 balancing, that everything getting from power to the DC side, the comm side, is going through every board on the outdoor unit. Everything's fine, right? So what I tell my class is if there is an issue with something, you have a check S1, S2 to S3, you either have high voltage or steady voltage is not balancing. Now we have to figure out, is it an indoor issue or is it an outdoor issue? Because you can easily go down a rabbit hole with our stuff if you don't know what you're doing. So I tell the guys, turn off power, right? Take your wire, S1, S2, and S3 wires off the terminal block, turn on power, and tell me, do I have 208, 230 on S1 and S2? Do I have a solid, right, 24 DC on S2 and S3? If I have a solid 24, my outdoor is doing what it needs to do.
Wire
Now we have, it's a wire or it's an indoor issue.
Right.
Stop what you're doing. It's
indoors.
It's indoor.
Connect the wires back up. And what I like to tell people, if I have on S2 and S3, if I have 0 volts with the wires connected and I have steady 24 volts with the wires disconnected, then I think most of the time the problem's in that wire. There's a short. in that
Correct.
wire.
Yeah.
Yeah.
Yep.
Good way to check that is maybe check the other end, see what's coming out.
Yeah, but I'm just before I go back inside, before I go all the way inside, I'm lazy. I want to sit there.
The other thing too is, especially if you start getting weird voltages on S2 and S3, check those fuses.
Oh,
'Cause
absolutely.
I this just happened to me recently where I checked an indoor unit. I first noticed powered up the equipment and the MA controller didn't come on.
Yeah, that's the first
interesting.
check right
So
there.
then I checked on S2 and S3. I had low voltage, but it wasn't fluctuating. It was just like 7.5 volts or something strange.
It's weird.
So I said, you know what? Let me just pull off S2, S3 from my outdoor unit. I did. Now I have 12.5 volts. Still not enough. Sure enough, one of the fuses is blown out. So if you start seeing weird voltages, you could have a crosswire situation. So verify that, but also check those fuses.
That's very common. It's a very common call we still get on the call center. S1, S2, S3, it'll be black, white, and red outside. When you go inside, it's black, red, and white. And,
Cross wiring.
Yeah.
I had one, when I first started here, I had one job site I went on with one of the area service managers, and that's what it was. It was S1, S2, S3. Outside was black, white, and red. And inside was black, white, and red. But the wires were crossed. And then it was 16 gauge outside and 14 gauge inside.
No wire nuts.
So I said,
Wire
okay,
nuts.
you must have a splice. And he goes, no. The guys, no, there's no splices. I go, really? So the wire just magically changed sides somewhere in the roll. So anyway,
It's a
I
miracle.
digress.
Yeah, you bring up these wires in S1, S2, S3. You have S1 is your true power.
Yeah.
Then you got S2 is a shared common, and S3 is our communication. People come, it's like, how does that S2 carry AC voltage and DC voltage at the same time?
No.
It's all about frequency.
It's frequency and the way the AC voltage actually travels on the outside of the cable, where DC is steadily through the center of the cable itself.
Yeah.
Yeah.
Well, if you heard from the last podcast, these are things that we pick up from Felix because he knows all about that stuff.
I know, right?
Last thing to check on the outdoor unit would be fan motors. Usually, and this is crazy, and I run into this a lot in class, is if you were to have like a rotational feedback error, it can take some time before the outdoor unit throws an error code. So you could even get the service call when the customer notices it, and by the time you actually arrive on that job site, it could still be behaving in this way of a rotational feedback error with still no error code. So this is where the pack tool comes in.
Oh,
because the
man.
pack tool will find that error code
Oh,
quickly.
right.
Love
The
that
pack
thing.
tool find it right away.
So if you do notice this symptom of an outdoor unit or even an indoor unit that runs for 10 seconds and then shuts off for 3 minutes and then runs for 10 seconds and then shuts off for 3 minutes, you probably have a rotational feedback error. Easiest way to test that is to know your pinout. So on fan motors, this is outdoor units. On pins 1 and 4, that's our feed into that fan motor, 300 volts DC, just like we talked about with commercial equipment. Pins 4 and 5 is our constant voltage into that. It's our rotational feedback voltage. It's 15 volts. On pins 6 and 4 is a speed control, so think of it like an ECM motor, right? So pins 6 and 4, if we have low speed, we might be at 1.5 volts. At high speed, we might see 5.5 volts. And then on pins 7 and 4 is that rotational feedback out. So the way I tell people to diagnose it is like a switch. 5 and 4 feed the switch, and every time that fan rotates, it sends 15 volts back out on pins 7 and 4.
Yep.
So when the fan is manually being spun, right, you have the system powered on but not calling for anything, and you manually spin that fan, you should see 0.15, 0.15 on pins 7 and 4.
That's a great test.
Yeah. The other way to do it is if you happen to have your meter leads in pins 7 and 4 when it runs for those 10 seconds, you should see 7.5 volts DC.
Yeah,
It's actually going to
meter can't
split the
pick it up.
difference.
Yeah.
So it moves too fast, so you won't see that fluctuating, but your meter will split the difference. And that's because it's really in there. It's like a Hall effect sensor, right? So we're actually looking at differences in voltage, not necessarily an actual switch, but you diagnose it like a switch.
Yeah.
If I have 0 volts on 7 and 4, I'm going to check 5 and 4, make sure I have the 15 volts there.
The only thing that will tell you on pins 4 and 5, that 15 DC constant feedback in, guys, it's not 15, right? You may read like 14.8 or 14.3, but it's just around 15 volts. Just wanted to let you guys know. Don't freak out and you measure that, solid true 15.
Yeah.
But
The nice thing too is you don't actually have to know the exact pins.
No.
If you grab any of our fan connectors, minus the FX unit, it's different, but any other fan connector, whether it's indoor unit or outdoor unit, you look at that connector, you will see a gap in those pins.
Yes.
It's either not using pins 2 and 3 or it's not using pin 2. The order never changes. So if you look at that connector and you find the gap, the outer wire is always your power wire and that middle wire is the common.
Yeah.
Then you just have to remember the order: power in, feedback in, speed control, feedback out. I don't even look at the manual. If I pull a fan connector, right?
Same
If I
here.
look at a fan connector, all I'm doing is finding my gap, and I just remember the order: power in, feedback in, speed control, feedback out. One wire stays in my common, and I use the other wire to do those tests.
Yeah, the pin by itself, that's your power.
Yep.
That's where I always go to.
Yep.
Yeah. My mind doesn't work that way. I don't even know what you just said. I already forgot it. So I could never memorize that. I need it written down somewhere.
Paul's thinking about red ginger.
Yeah.
Yeah, he is.
No, I'm much older than you, and that's what it is. It's like, what did you just say? I don't know. I'd have to
He's
write
looking
it
for the
down.
roadmap. Where's the diagram?
Yeah.
Yeah.
Every time I'll need
Where's
the
the
diagram.
manual?
Yep.
All right. Do we have anything else in the outdoor unit? Or is that it?
I think those are the vitals, right?
Yeah, those are
things
the
to check for
top
sure.
ones you need to check.
All right.
Yeah.
So let's move to the indoor unit. S1, S2, S3.
Yep.
That's, again, we already talked about the cross-wiring, the
checks.
voltages, what to check, everything else. S2, S3, it's the same. It should be the same thing we read outside. So what's the next place?
Check your power tier controller on CN22. Typically, CN22 is a connector that goes to a terminal block, so you can check either place. You can back probe CN22, or you can check the actual terminal block where those wires leads. That's your MA controller, 12 volts DC.
Yep. Another one is going back to the fan motors, right? So we're feeding from S1 S2, then that goes in, hits a diode, and we send that 300 DC right to the fan motor.
Yep. So again, check that.
That's
300 volts
just like
DC.
our city multi-boards indoor. It's the same concept.
Yep.
Yeah.
New with A2L equipment, CNSA or CN147. Pins 1 and 4 is 5 volts DC to the refrigerant sensor.
That's right, yeah.
So this might be helpful when you're getting, the 5558s, where you're not getting a refrigerant leak, but you're getting a sensor error.
A sensor error. Correct.
So now you go, okay, I have a sensor error. I didn't necessarily detect a leak, but there's something wrong. Is it my PC board that's my actual refrigerant sensor, or is it my control board on the unit not putting out
and
the
not
proper
setting out
voltage?
that voltage.
So a good check is, let me check pins 1 and 4 on CNSA or CN147, just depends on the unit.
Nice.
If I have the 5 volts, then I know it's a sensor. If I don't, okay, I'm doing control board at my indoor unit.
All right.
Nice.
And then CN4F.
Oh,
Yeah, that's your float.
Yeah,
right?
it's
Well,
a standard.
there's two kinds of CN4F depending on the equipment, right? I can have a CN4F, like I just put a PVA in my house, and that has a CN4F, which is just a loop of wire.
Yep.
Yep.
It's just comes out of one pin and goes into the
Normal
other.
closed. Yeah.
And that's just normally closed. But if I have a unit with a drain up machine or a lift up mechanism or a pump, that's going to have another 2 wires, which is normally
It's pins 3 and 4,
pins 3 and 4.
and that's going to be normally open.
That's right. That's normally open, and that closes to create a fault. So this is different than what we might be used to with float switches,
Yeah.
right? This float switch is going to sit at a certain level, and if the water's not draining, that float is going to rise up, closing the contact, creating a drain fault. It has nothing to do with turning on the pump or anything
Right.
else. So just be clear on that.
Yeah, there's also drain sensors in some of our equipment too, where it's just a thermistor, but same basic
Right.
premise.
It's just
Yeah.
Yep.
Yep.
All right. And anything else at the indoor unit?
Yeah, I think that's good.
I think that's it. So let's talk about branch boxes.
Yeah.
Because I think we talked about smart multi before, but I think we were focusing on with city multi heads.
Yeah.
Yeah, outdoor units.
Yeah.
Yeah.
Yeah. So let's talk about smart multi with the branch box.
Yeah. There's only a couple of things I'm going to check on the branch box. First is obviously incoming voltage, whether it's coming off of B1, B2 from my outdoor unit or from a separate circuit. L1, L2 should have that 208, 230. My MNet, 29 volts DC. S1, S2, S3 to all my indoor units, because now with a smart multi-branch box system, the outdoor unit is not providing that S1, S2, S3 voltage. It's my branch box.
Yeah.
So I may check my output voltage from the branch box to all of my indoor units, making sure that that communication and power is set up right.
And here's another important thing that I see happen a lot too, is that branch box is not only going to feed the S1, S2, S3 wires to an indoor unit, it's also going to feed the high and low side pressure pipes. You have to make sure that, because they're labeled, you know, the little 5 little boards are labeled A, B, C, whatever it is. You got to make sure that the same corresponding refrigerant lines go to the same unit as S1. Because if you cross those, in most, and I used to tell people when I was teaching, check one zone at a time or turn off one zone at a time and check the air temperature, make sure that's the one that drops. But typically what people do is when they start up a system the first time, they put everything to heat or everything to cooling and then check and it's done. But if they're crossed, you won't know it. The customer won't know it until, especially if you install it this time of year. We're in June or July here in Atlanta. It's always like 1,008 degrees here and 75,000% humidity. But they won't know if you did it here. They wouldn't know until possibly November, December.
Yeah.
We do a good job with tagging those though. A, B, C, D, E.
Right.
But things do get crossed up.
Yeah.
So
It's really,
be careful.
It's a lot of it is on the install side. I mean, when I used to do branch boxes, we would run our pipes like maybe a foot beyond where they needed to go. And then with the line, right, whether it's a whip or, whatever wire you're using, I would tape it right to the end of that piping. So I'm already running it with it. And then right at the end, I'm
sense.
taping them together. And it's like, and I would
nice.
label it. I'd love it. Oftentimes I would just write right on the line set, A, B, C,
Yeah.
D.
So you
and
know.
E.
Yeah.
And that way
Smart.
there's
That's a
no
good-
way to confuse
That's
it.
good.
Just
That's
don't let
good
it
practice.
dangle. And,
It happens.
Yeah.
It happens.
happens more than you think.
Yeah. One of the other things I'll check too on the branch box is the LEDs. There's an amber LED on there that flashes, letting you know how many indoor units are connected.
Yes.
Flash.
Yeah.
Yep.
So, and that's dictated by SW1 on the branch box. So, however many dip switches you turn on SW1 are how many units it sees or thinks are on the
Yeah,
system.
I don't think it's an error code because a lot of
an
people,
error.
a lot of people think it's an error.
Yep.
Yeah.
And I think that's it. Do you want to talk about the IntelliHeat?
Just a couple things.
Just basics.
Yeah, we don't have to cover all of it. And this is more just your basic HVAC review, right? The IntelliHeat is using 24-volt relay to call in a furnace in the event that the heat pump either doesn't keep up or we're below our balance point. So what happens when we walk up to an IntelliHeat system and it's below our balance point and nothing's coming on? Do we blame the IntelliHeat control box? Do we blame the furnace, right? So some things that we can check on terminal block A, which is our wiring that goes from the IntelliHeat control box down to our furnace. If I'm supposed to be in heat mode, I want to check W and C, right? I should have 24 volts
24
across
volts.
W and C. If I'm in cooling, right, the cooling is just going to tell my furnace, it's obviously not a case coil, but it's going to tell it, hey, run in high fan
Yeah,
speed.
fine. Yeah.
So I should see 24 volts on Y and C and also 24 volts on C and G.
Correct.
Tell
For your
my fan to run.
Fan. Yep.
Yep.
Yeah.
Now, that all gets its signal from terminal block B. Terminal block B is where we're going to land. If we had a third-party thermostat,
Yeah.
we're landing our thermostat wires on terminal block B. If we're using an MA controller or an MHK2, something like that, we do still have some things on terminal block B. One is that
That's for
non-adjustable thermostat.
If you're using Mitsubishi, we'll call it Mitsubishi controls.
Yeah.
Right. Then we'll have what we call something for emergency heat.
Yep.
Right. Because if you're using a PAC 445 third party stat, right, we can use that particular stat for backup heat for emergency heat.
Sure.
If we're doing Mitsubishi controls, we don't have that option.
Right.
So then in this case, we have the NAT sensor, non-adjustable thermostat that we land on R and W.
Yep.
So basically when the system goes in emergency heat, then we activate the 24 AC to activate the heat with the furnace to run.
Yeah,
Basically.
when that non-adjustable thermostat is just mounted in the return.
It's a switch.
And essentially, right. And once we fall, let's think of it like a T87 thermostat. When we fall below a certain temp, which in this case is about 60, 62 degrees, it's going to close, and then R&W energizes to kick in our furnace.
This is where I recommend, where I tell my contractors, like, look, go to Home Depot, buy a $20 stat,
can do that
and then use an actual thermostat to adjust to emergency heat. The homeowner will now have control, just rather than for the NAT sensor, you're already wires for R and W, right?
Yeah.
Just run R and W to your stat, and then now the homeowner has control of the furnace when it's an emergency.
A lot of times, homeowners don't know what that stat is.
I know.
Unless you put a dial on there and tell them,
that's the-
then
that's-
that is something that they don't understand.
Right. That's the conversation you do have to have is, hey,
Oh,
I'm putting two thermostats on your wall. One is the thermostat you use when everything's normal. This is only when your heat pump fails. System's not even going to run.
Yeah,
off
that
this
would almost
thermostat.
like you would probably install it, but leave it at the furnace. I don't know, right?
because it's sensing
you
room
can.
temperature.
Right on
So again, it's one of those that
It's one of those.
I'm going to be
tuck
very
it away.
selective who I do, there's some
exactly.
people
It's
I'm
one of
not
those
talking
that
about.
it's there, but you know what I mean.
Which is why we have the non-adjustable thermostat. It
Correct.
comes in the package.
Yeah.
It's turnkey. Just be careful where you mount it if it's any outside air coming into the
Thermostat
return
for
duct.
dummies.
Yep.
All right.
Cool.
That's it for the IntelliHeat?
You know?
Yeah, I just wanted to cover some of that 24-volt relay stuff.
Yeah.
Brandon, let me ask you a question. We kind of missed it a little bit, but let me ask you this. What is the only product that we have that does 24 volt AC?
The only product that we have?
Yeah, we have one system.
I know what it is.
Talking about the City Multi-Branch box?
Yeah.
Okay. I was like, I thought you were talking about a controller. I'm like,
That wasn't that hard. Even I knew that.
yeah, so City Multi-Branch controllers. Yeah, it's a good point. We should bring it up. I mean, there's really not a whole lot of voltages
No,
to
it's
check
not.
in
But
that branch box.
but that
which is
one's
why
a
we left
tricky
it out.
little one, the little bugger to actually know because through maintenance tool, if that transformer goes right,
No error code.
no error code, it just powers off.
Yep, nothing runs.
Nothing runs.
The only indicator is that your branch controller will show power outage on maintenance tool.
Yeah.
But you will not get an error code. You will have communication voltage. You're like, what the heck is going on? None of my units come on. The unit is just
I
stagnant.
mean, you'll have line voltage going in and all that. Yeah.
Everything. But it's that 24-volt transformer. Now, is it going to blow off? And probably not unless there's a short in the board somewhere. But it's something to be aware of. Especially if you
I
do a
don't think I've
maintenance
ever
tool
heard
search.
that even going anyways.
Yeah, and that branch controller is
It's-
showing
yeah.
power outage. Check
The
that
only
transformer.
The only time I've ever seen a 24-volt transformer go is when there's a short on the low voltage side.
Okay.
Right.
Right, or something fries it on the high end, some spike or something. So it's very rare.
Rare. Yeah.
Like maybe, like Roland would say, there's some lizards in the branch controller,
Lizards.
and they chew through the wire.
Miss Roland.
Lizards.
Yeah. All right.
Nice.
So I think that's it. You know what's impressed me is you guys are sitting here rattling these off. There's no diagrams in front of you. There's no test point diagrams. There's no nothing.
I
you
have
guys,
nothing.
You guys are you're just wicked smart. Wicked
smart.
Yeah. Yeah.
It's a good one. I think this is helpful. I got this idea because you had sent me some of the requests for things like podcast ideas and tech links.
Yeah.
And, we talk all the time about all these voltages. People will even sit in our class, and by the end of the voltage or the wiring diagrams, their brains are like melting and they're starting to nod off. These are the quick checks. These are the things you walk in, check these, especially if the system's not running and you don't have an error code. Check these. These will get you your answers quick.
Yeah. And we just got a comment. Steve was telling me about it. A comment. I didn't know this was even possible, but on Spotify, somebody commented that they have hundreds of systems out there, units and multiple rooftops, and he listens to the show. It's always on in the background. He loves the show. So, he's always educating himself. And you can hear the same thing over and over and over again, and it'll finally stick, and someday you'll memorize it.
I know.
So it's good. So I'm glad. So we welcome the ideas. Like, again, we've got a couple. I know Nick has sent us a few recently and a few other people, but yeah, we're always looking for ideas. We want to make the show valuable for you out there and educational, entertaining. You can send us food ideas. We're running out of food ideas.
Well, and to your point, Paul, it doesn't have to be right about our product in particular.
Yeah, if you want to do something general refrigeration, general HVAC, thermodynamics, we'll have Gary do that one.
Yeah. We'll slow
Where do
down
we start?
on interviews.
I'd love
a
to
little
do one. I'd love to do one on the psychometric chart. Brent and I were talking about the psychometric chart.
Oh,
the
I'd
other
love to
day.
join you on that.
And the most interesting thing, the amazing thing to me is Willis Carrier developed that psychometric chart. I want to say it was 1911 or something like that.
yeah.
No computers. And it's still true today. So in the information it can get you from dry bulb, wet bulb, relative humidity, grains of moisture, pounds per cubic foot of all these things. Any two, you can find out all the others.
Yep.
And now they have, there's probably an app for that.
Well, everything is there.
Oh, there's an
field
app.
piece probes.
Yeah.
There's a meter. There's a
It's
meter.
amazing. But I could geek out on that all day. And I'm just going to be honest with everybody. There's more that I don't know about the psychometric chart than I do know. At one point in my education career, I used to teach it to entry level students to a certain point. I really got into it, and I loved it. And that's just the topic. That and thermodynamics. Tough for me to learn when I was in school. It's even tough to explain to somebody who knows nothing about it. But I love those geeky topics.
As a tab guy, I had to live on it
Yeah.
on some of my jobs. So, yeah.
Also, stay tuned
prefer
for
Diet
all of
Coke
our,
to tab.
we have a lot of upcoming products in the next year, so stay tuned for the podcast on those.
Yes.
when
It's
the
going to
time
be,
comes.
and I think what we're going to, so I think most of us in the industry, if you've been under a rock somewhere for the last year, but the A2L transition first happened with residential equipment. That took effect this past January, 6 months ago. On the commercial side, the A2L transition is going to happen effective this upcoming January. And I think we had 3 or 4 or 5 podcasts on the A2L transition. And there's no need to repeat what we've already done as far as when it takes effect. But it's the same thing just a year later.
Yeah.
So we'll be doing podcasts on that closer towards the end of the year. There's some hydronic products coming out, some updates to other hydronics products coming out. So
Cannot wait.
we'll be doing those a little.
A lot of water.
Yeah.
A lot
A lot
of
of
water.
what?
Water.
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 So, don't you mean water?
Water.
All right. Speaking
All right,
of
let's
water,
get to some General So's.
yes.
Or
I'm
Mother
gonna get a Benito box.
Benito box.
All right. Take care, guys.
See you next one.
Bye, everyone.